Now we're revisiting domain and range. Remember that domain is the set of x values and range is the set of y values. So in graphs like 8 and 9, the new thing, the reason why we're revisiting domain and range here is these are what are called continuous graphs. These are continuous. So before, for number 8, maybe for the domain, you might be thinking of how we were treating it before, and we could say, oh, well, the graph passes through x value of -2 and -1 and 0, and we could list out all these x values. But the issue is, yes, the function exists at x equals 0 and exists at x equals 1, but it also exists at x equals 1.5, right? And 1.25 and 1.2 and, different irrational numbers. So we have to account for all of those different values. So for these continuous functions, we're going to be writing our domain and range. I'll primarily write these in interval notation, but I'll also rewrite these in set builder notation. So you can see what that looks like. So starting with the domain, remember that domain represents our x values. So to find the domain, we want to go from left to right on our graph. How far to the left our graph goes and how far to the right. So along the x-axis, I can see that my graph goes as far to the left as -2 and as far to the right as +2, okay? So it doesn't exist over here to the left, it doesn't exist over here to the right. So for my interval, my left-hand x value is going to be -2. My right-hand x value is going to be +2. Next to the -2, because I have this closed circle, I'm going to put a square bracket. That means that x can equal -2. Up here at +2, there's an open circle, so I'm going to write a rounded parenthesis because x can't equal 2, but it gets really close to 2, but never equals 2. All right, so now we're going to switch gears. That was for domain. Let me erase all of this stuff. That was for our domain. So our domain is in interval notation. Now let's look at our range. And for our range, we're looking at our y values. Our y values travel up and down, right? The lower values are down, and the greater values are up on our y-axis. So now we're seeing how far down and how far up our graph travels. The lowest our graph goes is at a y value of -2. The highest up our graph goes is at a y value of 4. Okay, so these are going to be our values in our interval. We write the down number, the lowest number first, and in this case it's -2, and then 4 on the right. Because I have a closed circle at -2, I have a square bracket. At +4, I have the open circle, so I'm going to put rounded parentheses. All right, and rewriting these in set builder notation, the domain, I would write the set notation, the squiggly braces, x such that, and then I'm going to write an inequality representing that interval. -2 is less than or equal to x is less than 2, and then squiggly braces. So that would be my domain in set builder notation, my range in set builder notation, y such that -2 is less than or equal to y is strictly less than 4. Okay. So let's take a look at number 9. Again, first I'll write my domain. This is going from left to right. The farthest to the left my graph goes is -4. And then going to the right, my graph keeps going and going and going to the right. So -4 is going to be my left-hand value for my domain. It's a closed circle, so square bracket. And then going to the right, I'm going to have positive infinity. Remember that on my x-axis, here's -infinity, here's positive infinity out to the right. So I know a lot of students will say, oh, why isn't it -infinity over there? Well, first of all, -4 to -infinity is an invalid interval. No matter what question you're answering, -infinity never goes on the right of an interval, just as a reminder. And also, we're just talking about left to right. So going to the right, x is getting more and more positive toward positive infinity. Okay. Now let's switch gears and talk about our range. So for our range, now we're going from down to up. So down, our graph keeps going down and down and down indefinitely. And up, the highest point I see is at y equals 2. So the lowest value, because we're going down toward negative infinity on the y-axis, we'll have negative infinity going up to 2 square bracket. The reason it's a square bracket, even though I don't see a closed circle here, unless you see an open circle, you can assume that the graph passes through that point. So like we're assuming that the point 2, 0 exists on this graph because they didn't go through the trouble of putting an open circle there, okay? All right, and in set builder notation, this would be for domain x such that x is greater than or equal to -4, and for range y such that y is less than or equal to 2. All right, and finally, let's take a look at intercepts on the graph. So we're trying to identify the x and y intercepts. So for number 10, this is anywhere that my graph hits the axes. So for my x-intercepts, looking along the x-axis, I have 0, 0, as well as 4, 0. And along the y-axis, I have 0, 0. On number 11, first I'm going to just identify any time that our graph hits an axis. Looking along the x-axis for x-intercepts, I have -4, 0, -2, 0, 2, 0, and 4, 0. And then along the y-axis, I have 0, 4 as my y-intercept.